I am Giovanni Cahilig from National Kaohsiung University of Science and Technology, and today I will present my research titled Renewable Energy Innovation Efficiency Assessment of the world's highest ranking countries for green living. And this study focuses on evaluating whether countries that are widely recognized as green are actually efficient in converting renewable energy resources into meaningful outputs, such as energy production and economic performance. Now, to begin with, global energy demand has been steadily increasing due to industrialization, technological advancement, and economic growth. At the same time, countries are being ranked as green based on indicators such as environmental policies, sustainability initiatives, innovation, and overall quality of life. However, this raises an important question. Do these rankings truly reflect how efficiently countries use renewable energy? Most existing rankings are perception based, meaning they capture how sustainable country appears rather than how effectively it transforms into inputs into outputs. Now, this creates a critical gap. A country may rank highly in sustainability perception, but may not necessarily be efficient in practice. This gap between perception and actual performance is the primary motivation for this study. Building on that, the research is grounded in a key observation. There is a growing mismatch between rising renewable energy demand and actual efficiency performance. As energy increases, emissions pressures also continue. However, existing green rankings often do not reflect how efficiently countries manage their renewable energy systems. This suggests that being labeled as green does not automatically imply efficient energy use. Therefore, a more objective and performance-based evaluation is necessary. Based on this problem, the study aims to achieve three main objectives. First is to evaluate the efficiency of renewable energy systems across top green living countries. Second is to reconstruct country rankings using a data-driven efficiency model rather than perception-based indicators. And third, to identify the gap between perceived sustainability and actual performance. Overall, the goal is to provide a more accurate and quantitative perspective on sustainability. This study is supported by two main streams of literature. The first focuses on green living practices and sustainability policies, which emphasize environmental awareness and policy frameworks. The second focuses on energy transition, which examines how countries shift from conventional energy sources to renewable systems. While both are important, they tend to focus more on policy and perception rather than measuring efficiency directly. This highlights the research gap that this study aims to address by applying quantitative efficiency model. The methodology follows a structured research process, a selection of countries as decision-making units, data collection from international sources, identification and classification of variables, application of the efficiency model, and analysis and interpretation of results. Now, but before we proceed, it is important to explain that the data set that we have used here is from 2017 to 2020. Although this may appear outdated given that we are now in 2026, this choice is intentional and justified. First, global data sets, especially energy-related indicators, often have reporting delays and inconsistencies. The selected period ensures a complete and comparable data across all countries. Second, the DEA model used in this study requires balanced panel data, which means consistent data across time. And lastly, the data set captures both pre-pandemic and pandemic periods, allowing us to observe how external shocks affect efficiency. Therefore, the dataset is selected for reliability, consistency, and analytical validity, and not just recency. The countries analyzed in this study are based on the best countries for green living that was ranked in 2021. It was developed by Wharton School, BAV Consulting, and US News. These countries include top performers in sustainability perception and are treated as decision-making units, or DMUs. Each country is evaluated as an independent system that transforms inputs into outputs. At the core of the methodology is the classification of variables into inputs and outputs based on production efficiency framework. And the variables were obtained from international datasets such as the World Bank and Global Energy databases to ensure comparability across countries. The classification follows a simple principle. Let's go back to the previous slide, please. Yes. There. The classification follows a simple principle. Inputs represent resources consumed, and outputs represent results produced. These inputs include energy consumption, renewable energy investment, and capacity indicators. These are considered inputs because they represent the resources required to operate the energy system. And the outputs include energy production and GDP. These are considered outputs because they represent the results or outcomes of resource utilization. This can be summarized as inputs, energy system, and then outputs. This reflects how countries transform energy resources into economic and production outcomes. Now, step 3 is validation. Before applying the model, Pearson correlation analysis was conducted to ensure the inputs and outputs have a valid positive relationship. And if you would see here in the next slide, the resulting values for Pearson correlation is -1, 1, and 0. So if you get a -1 result from the values that you have just gathered, the DMUs are not compatible with each other. Same thing if it's 1, it's the other way around. Finally, step 4 would be a data envelopment analysis with window analysis was applied. This method evaluates how efficiently each country converts its inputs into outputs over time. And these are the equations related for the Pearson correlation test and the DEA window analysis. Now, the results show that overall efficiency levels remained relatively high from 2017 to 2020. However, there is a noticeable decline toward 2020. This decline suggests that external factors, particularly, I think there was the COVID-19 pandemic, had a negative impact on efficiency performance. The final efficiency rankings reveal that Switzerland, Norway, and the Netherlands are the top performing countries achieving near perfect efficiency scores. On the other hand, Germany, New Zealand, and Finland show relatively lower efficiency levels. And this indicates that countries with strong sustainable or sustainability reputations are not always the most efficient. And to compare, from the rankings that we had in the first slides, when comparing perception-based rankings with efficiency rankings, clear inconsistencies emerge. Some countries that rank highly in green living do not perform equally well in efficiency, which confirms that perception does not necessarily reflect actual performance. From the analysis, 3 key insights can be drawn. First one is consistency is critical. Countries that maintain stable efficiency perform better overall. Second, fluctuation reduces performance. Inconsistent efficiency leads to lower rankings. And third, efficiency is cumulative. Long-term performance matters more than the short-term gains. And as a conclusion for my report, being ranked as green does not necessarily mean being efficient. True leadership in renewable energy comes from sustained and consistent efficiency. Countries like Switzerland and Norway demonstrate this through their ability to consistently convert inputs into outputs effectively. Um, and for my final message, this study contributes by providing a data-driven perspective on sustainability, challenging perception-based rankings, and highlighting the importance of efficiency. And ultimately, sustainability should not only be judged by how green a country appears, but by how efficiently it performs. Thank you very much, and I hope that everything is clear. Would there be any questions?